uh, uh, Day School 3, EEX3417, Software Development for Engineers. This has two sections. Simulation software, Octave, applying and introduction. And then the second part is database management system, data modeling, database management systems, data modeling with ER diagram. I think most the Octave is similar to the C programming. It is very much focused to the mathematical calculations. This Octave software is very much similar to the MATLAB. The MATLAB is a paid version, and we don't have a paid version, and you can use Octave also if you can use, better to use MATLAB. Most of the time you can do your projects and simulations using MATLAB. Now actually Python also has huge libraries. This also has libraries. The MATLAB also has more libraries, and now but MATLAB is a proprietary software. What is this? Python is open source, and programming there, it's a programming language. You can get freely. You can freely import lots of libraries. Actually, they are improving. Even you can create your own libraries also. Now I will start by introduction to data modeling, and that is second part. And then I will start, if time available, I will start the simulation software. This simulation software is very much like C programming concept. Data modeling. Introduction to the data modeling and database management. Data modeling is ER diagram. I will explain later. ER, what is ER diagram? Then normalization. Content, data and information. Actually, these all are given in the book 2. Book 2 has mainly database and data modeling. Database management system, relational data model, normalization. Actually, in your book, I think the book 2, you can see this data and information, all those things in book 2 under the data modeling. Here is a database management system regarding the data in organization or any specialized goals or specialized goals like NIC number, creating NIC number, like NIC card. It has details about our in every person's in Sri Lanka. Like that, we can store data in actually earlier, before common computers, and also now also, data stored in letters, as a letters, paper letters. Most of the government organizations use these paper letters, but that paradigm has shifted to the software. All the paperless, actually. Now, how it can do is we can store data in computer. Earlier, it is data stored in a single computer. Now what happens is they are stored in Google Drive or cloud. That is a new trend. Now, what is data? Now, one data is now here given two examples. One data is Sadali Karnaratna, second one is number. So there are two data, but no meaning. But if we say registration number of the students on Sadali Karnaratna is 71834,001. So that has a meaning. We can say that registration number is this. Now earlier, we have only the data. There is a difference between the data and information. So actually, we store separate data in computers, and then we can retrieve data, and that using those data we can create information using the database management systems. How can we store data? Filing cabinet, that is actually box, right? In the physically, we can keep letters and put some letter in a file and put them in a cabinet. Another one is spreadsheet. Spreadsheet is like Google Sheet, Excel sheet, like that in computer. Folder. Folder is also like separate place, paper, and also in a computer we can use folders. Ledgers, lists, piles of paper in a desk. That is, these are paper and both in computer. File-based systems. One way to keep information on a computer. Earlier, we kept computer files. Actually, this regarding the not the paper files, computer files. We can create folders like personnel department, employees, salary details. Like we can create separate folders in our computer, and this organization has three departments: personnel department, workshop, inventory handling. Inventory handling is supply station. So there are three departments. So we can put three computers there, and we can put employees details in one computer, employee details and salary details in one computer. So inventory, that means information, data regarding that physical parts, or those like tables like that. So we can put numbers. We can like table number. We can put numbers in on every table, chairs like that. Then organization. So we can store them in a computer. But we can create separate things. But suppose now here the spare parts folder has in two places. Here inventory handling and also in workshop. Spare parts are available there. And suppose employees worked in workshop also, maybe they need to store separately. Other than that salary department, workshop may also need to store their employees in workshop. So same name can be keep in two places. Suppose personnel department, employees number and all details, and workshop also. Same name may be in two places. So suppose employee name is wrong in one place, so we have to inform to the workshop also. Sometimes they don't know where they stored. Sometimes in inventory handling also they have employee number. So in different places, same name may be available. So if the one name is wrong, suppose simple letter is missing or something. So in three places, we have to say this letter is not included in this place. So very big issues may be there when the employees and this information are big. Disadvantages of the file-based approach, that is a data redundancy. Data redundancy is same data in several places. Concurrency access means sometimes in one places we can change it. We can change the whatever errors, but we have to change it in other places also. Data isolation. Isolation also like that. Same data may be available several times. So in the one department, they cannot access into the other department's data. If they want some information about information from the different departments, one department cannot get immediately. They have to write to the head of the department, and sometimes it may get times to about 1 month. If this database management systems available, we can get information in a few seconds. Not from this approach, we may have to get about 1 month. or 2 months, because sometimes we don't know where those data also available. Integrity problem. Integrity problem is also like when we update it, it doesn't update if when you want to update it, it doesn't update in other places. Security problems also available. Sometimes different people can change, modify, and access, modify, and delete in one places. Sometimes in other places available. They don't know what happened. Database stored in a computer system, shared collection. In a database, now we talk about relational database management. In relationship database management system, data can be shared. Connection of related data. We can gather data in related data in one table, and different tables are there. We can connect these tables and we can use. So, we can use and we can share the data available in central place, but we can access them from the different places. So if we update, we can update the name like name in a single place, used to support activities in a particular organization or some in an organization. This is a database example. Student details of a university. These are shared. These can be shared, related particular organization. Related mean these. There are two tables here. No, there are four tables here. One is student table, other one is marks table, other one is course table, and program table. This student info is a database. This complete database name is here. This database name is student info. Table name is here student. This table name of this is student, and these are called attributes. Data about data belongs to the student. Student registration number, student name, student date of birth, student gender, student address, student telephone number, P code. Here, this P code is this program code. We can get separately store program code, because even this student is not available, program code should be there. Program code and program name should be there. So we can get separate. When a student registered, we can create this data and we can connect this program code to here. And marks. Marks, student registration number there. Course code is this one. Course code, course title, credit, number of credit level. So we can connect this course code to this one, and we can connect student registration number to this. Then we can put marks separate in a separate table. So like that, in an organization, we can put separately, create data in a related data to one table, and also like that we can create several tables like that. So we can store them, and also we can create links from this each table. Then we can access in different department in same data. This is database management system. There's a database management system in software. In lab 3, we will give MySQL. You can create, there is a software called SAM. It has a MySQL is a database management system, and connection MariaDB, and then we can write application software using PHP in the web. Using a web, we can access from the anywhere. We can create a database in the computer, and we can share it into different places. These queries mean we can get details of database using some commands. These commands, we call this command as queries. And using, we can include in high-level programming languages also to access this data. Okay. Examples of some simple larger database management systems: university database, credit card processing systems, airline reservation systems, banking systems. Then many more databases are available. Layers of data abstraction. There are 3 abstraction: external schema, conceptual schema, and physical schema. We will this I will explain using example. Okay, otherwise you will not understand. Here, this physical schema, we can create actually the create data tables separately, and then conceptual schema is we can create links here, and then we use this data we can create separate tables for whatever we need. That means for the registration, when you go to the registration blocks, these data are stored. Here, what are the data? Course code, course title, registration number, name, registration year. And these are the data according to this one. Okay. Otherwise, actually, we store more than this data, but for this example, we store in registration block course code, course title, student registration number, student name, and registration year. In registration block, here VVEE mean we can view this course code. Course codes are created not in registration. Academics are created. Academics create the course code and course code and course title. But here at registration block, you can edit registration number according to this one. Registration number here in the Open University, registration number also created automatically. But according to this system, you can change registration number, name, and the year. Edit means you can store. Here, enter marks. Now, after the registration, after course is completed, you have, or in between that, you have to, and you have to this done from the academic. This register, this view is used by the registration staff. That may be academic or non-academic. Here, academics are updating this enter, but here academic can view registration number, student name, course code, course title, year registered year, and they can view. So they can edit marks. You can edit mean they can add, edit, they can change and delete or delete. Those facilities are available for the academic. Only we can change, academic can change only the marks. So those are the views. But without this application means front-end software, without this software also we can edit, but you have to type queries and comma. You have to get the queries. You have to write the query for this one to get this one, and to update also. So it is very difficult. Therefore, there is an application software. It is very easy to and nice front-end view, and we can easily update using this application. This application can be written in many languages of Java. So now for this lab 3, we use PHP to do this. And this can be done using the MySQL. So all these connections now this application and this MySQL also has there's a app connection software available called MariaDB. MariaDB and the MySQL also available in Apache. Or Apache is included in SAM software. I will explain by SAM software. You can use either WAMP or SAM to do your projects. You can try actually in your home also this lab sheet available. So you can try this and you can come to the lab and where you can do it very easily in the lab. Here these are users. So I think this is physical schema, conceptual schema, views, application software, users. I think, do you have any questions up to now? One question is there, so do we have student access to MATLAB or Octave? Octave actually you can get freely from, you can download freely. You can search, download that Octave, it is free. So I also use Octave because of this free to teach. And MATLAB is a proprietary software. I think we had software, but it is, I think, license has expired. You can get other ways also. Any problems regarding this? Okay, now all these things available in database management system and application software users. Relational data model. As I told you earlier, the student, marks, course, program, all are related. Related mean this student registration number is related to the these student registration numbers should be all are same. When you enter marks, student registration numbers should be available in student database, student table. Otherwise, we the student marks cannot be entered. This relation is called one-to-many. I will explain what is one-to-many. Here you can see this big circle. Big circle is many side. The small circle is to one side. Actually, there are four types of relations: one-to-one, one-to-many, many-to-one, many-to-many. But practically available only one-to-many relation, one-to-many and one-to-one also there. Sometimes it is there, but sometimes you need one-to-one relationship. One-to-many is the many as many table. ERD. I will explain now. Before starting ERD, I will show you the MySQL exam software. I am using the Ubuntu, so these are the commands in the command line. But you can, I think, you can get interface also, API also to run this. But I run using command prompt. So here, this already started. This lamp is SAM software. Here, starting Apache, MySQL, and this one. Apache is a web server to connect to the this server to the other side, users side computer. These connections are creating by Apache, and MySQL is the database. And between those things, you can use PHP also. Database connectivity is done by the MariaDB. And here you can run. This is PHP MyAdmin software. This is all this software you can get download and install freely. That is why I use them. PHP MyAdmin. You can this PHP MyAdmin. You can easily create database, and you can get you can create queries also. I created a database called earlier. Before starting this, I created a database called student. Now in student, I created a table. table called student. Now I created a student and the registration number. We will we'll add one more name. Save. Now here, registration number, we can create as a primary key. We can in every table you should have a primary key, otherwise you can't access. Here this primary key indicates by this key, this symbol. Now we can create another table, suppose course code. The type of this key, there are several data types. Several data types are vacha, text, date, decimal, like those things. Data type. This we call this as attributes. Attributes, we can each attribute has a data type. We will put this integer. This integer means only we can input only numbers. Here, postcode is the primary key. You can save it like this. Okay, now we will we can create practically these theories using this PHP MyAdmin and the PHP as a web using web interface to get data using a web. Now I will explain this. Now external schema is like this one, views, different views. Conceptual schema is defines a logical structure. Conceptual schema. Physical schema is tables. Database management systems, view 1, view 2, view 3. Now, in this example, only we have given only 2 views. There are so many views. Conceptual schema, physical schema, disk, that is database. This also. relational database, like with these colored tables have created by this PHP MySQL. Relational data model, NERD, or entity relationship diagram. Uh, uh, Now, when the organization want uh, uh, what, this their organization uh, wants a database system, first they call to the software company. What the software company is doing is they analyze the system, their existing system, and then uh, they propose a new. Uh, they get all the data, information, and these forms and all those things. There will be several interviews. So after analyzing this system, they created these tables. Before creating tables, the analysis separate. Uh, they write a document. By using this document, they create entities and the relationships. The one this one type of this statement is a student may register for 0 or more courses. Now in this one, this sentence belong to a academic institute. There are students and courses. So student may register for 0 or more courses. That means one student can register either one course or two courses or three courses, like that. May register mean student also without getting any course. So we write may register. Student may register for 0 or more courses. That means 0 mean no courses. More courses or mean one or more than one. For this statement, we can write entity relationship diagram. How? We get all the nouns and verbs from this sentence. One noun is student, other noun is course. So we can put entities as a square box. The verbs is register. So these verb can be write as register in the diamond box. Here you can see this is a diamond box. This is a square box. So these are entities, and this is relationship register. So this is in ERD diagram. Only these things available. This relationships and entities. I have to say this is entity. This is entity. This is also entity. This is a relationship. This one many to this mark is this we call crossfoot here as a crossfoot. That means foot. This is like a foot of a crop. There are three lines here. This student to course relationship is student to course is many to many. I will explain what is many to many. Right. Here you can see the student now. Student names are available. Nimal, Namli, there are several names. But courses are also available here. This student can this course. This student has got this course, and this course. There are three courses. This normally has got registered for three courses. Kamal has registered this course. Sadhun has registered for these two courses. Malik has not registered for any courses, and he has registered for only studentship. So he has not he has not registered for any course. So this is called this. You can see these. There are lines here like that. Three lines here. Many lines from here. Both sides you can see lines. So it is many to many. This one is one to many. This side is one to many. So both has one to many relationships. So that means that is many to many. We can, but practically we can create only one to many relationships in MySQL, that is PHP MySQL. How we can do it? We have to include relationships between them. Now ARD. Now here you can see entity is an object in the real world with an independent existence and can be differentiated from other objects. Actually, this is an independent existence. Student, course. Student is independent and course is independent. An entity might be an object, physical existence, lecture, student like that, or conceptual existence like course, job for position. Entity can be physical object or conceptual object, both can be available. Each entity is described by a set of attributes. Entities attributes are for this student entity. We can write name, address, gender, age are attributes. Attributes are attributes are properties of student entity such as student name, address are called attributes of the student entity. We write and we draw entity as a square box and attributes as ellipse boxes. Address, name, gender, age. What is this? This attribute? It is actually generally student has name, address, and gender and age. These things are available, but registration number is not available. But we can uh, we have to create a new attribute as a primary key. A primary key is a unique ID to understand, to identify the student. Actually, normally, we identify a person, not only the student, a person by his or her name. But name in different places, you can see in Facebook also. If we type same name, different people are aware. If we search, we can search bar in Facebook. If we search one name, we can identify different people for one name. So we cannot get actually as a primary key. Primary key is a unique key. Unique mean uniquely identify, especially one name to identify the student. So we create registration number as a unit number. So even uh, to sometimes with this initial same name available. I know same name available with this. If we write put the surname and the initial, same name available for different people. So we in an organization, this organization create a registration of a unique key for each student, not like the student. Actually, persons. We all have NIC number uh, for the driving license. Also, driving license number like that. They give the unique number for that to identify each person. In here we can draw each primary key. This is primary key actually. This registration number we can underline to identify the primary key. What are the attributes for a student, teacher, textbook? Please type for what are the attributes of textbooks? Textbook. Can you check or talk? Anyone can talk. Okay? Just think what are the attributes of a teacher and textbook. Please chat. Chat even you can say didn't understand this one. Oh, what is the problem?
Postcode classes.
Sorry. No, talk. Anyone can talk. I could hear you. Name, subject code, for what? Units for what? what is the entity? Now here there are three. Okay, now right. Okay. Unit subjects. I think these are for the now. Say what is the textbooks? Textbook attributes for a textbook. Textbook actually ISBN number, title, number of pages. Only related to the attributes are uh, those things only related to this entity. Textbook attributes of textbooks are ISBN number, title, number of pages, the number of sessions, so number of chapters, like those things. Now we can write separate entity as a one-to-many relationship, number of sessions, one textbook's session. Session has a we can get session as a separate table. Okay, thank you replying. Few of you have only replied. Didn't understand clearly? Okay, I will go to the next slide. Types of attributes. Simple attributes, atomic value, that is name, age, only one value. Composite attributes consist of hierarchy of attributes. These composite attributes are like address. Address has several other attributes also. One, we can get actually address as another entity. Address as a number, street, and that city and city name. Multi-valued attributes. Value of each entity. Have a set of value for each entity. Educational qualifications. Educational qualifications also not a single attribute. This attribute has several other uh, details. So we can get also another entity like certificates belongs to the one student. Certificates also one to many. Derived attributes. Derived attributes can be get from example of this derived attributes is age. Age, you can get age from this date of birth and the today's date, dividing today's date to the date of birth. So we can derive attributes, age attributes from these another attributes. Key, an attribute of for a group of attributes whose values can be used to uniquely identify an individual entity in an entity set. Now, what is the attribute of a student? Can you chat? Primary key, okay. Can you chat what is the key, primary key of a student? Just guess and yes, registration one registration number. Yes, and course. In your course, what is the prime? What may be the primary key? You can identify. How do you identify a course? Yes, course code. Only one is answering. There are 56. Um, any of you can even you can ask questions also. Yes, course code is a primary key, but what is the uh, now here student is available. Student is available. Marks is course is available. Program is available. You can see this primary key of this student table here. Registration number. Course has a primary key of course code. What is the course code? Marks. What is the primary key of marks? Yes, you can guess also. Right? No, actually, registration number. No. Here for the marks, uh, there are three attributes to get the to access this. Actually, you need primary keys to access this table. To access this table, you need student registration number, course code, and the registered year also. For the marks, to get the marks. All three attributes should be available. So it is a composite key. We call it as a composite key. All others, this is a relationship. This relationship has um, more than one attributes for key. But when you consider student, well, these are entities. Student course is entity, marks is relationship, and in student has only uh, one key, primary key, and course also has only one key. But to access this marks, you need all these registration number, course code, and registered year. Types of keys: candidate key, composite key. Candidate key is now when software company analyze, uh, they separate data and to the table. Then they identify what is the best uh, attributes to give a primary key. So that is called candidate key. A key is a simple or composite key that is unique and minimal. So its predigit should be minimal. No, unique. It is a unique because no two rows in the table may have the same value at any time. That means, consider your registration number. Registration number is in registration number of one student has only that key. That key belongs to only one student. Otherwise, if one key has two students, it will be a big problem for the university or any other, because some in NIC, two people have one NIC number, that is a big problem. So that should be unique. And the composite key is combination of two or more multiples, combination of keys, like yeah, attributes in marks. Marks has course code and the student number, registration number, and here that is called composite key. Primary key, foreign key. This primary key is a candidate key selected by to be used as an identified mechanism for all entity set. Is indicated in the ER model by underlying attribute. Here you can see this underline. So attribute key is underlined like this. When you draw, the foreign key is now here. Now you can see this student table has one primary key. Now course has primary key. One primary key. Program also has a P code, this primary key. But here you can see same. This actually, when you create in MySQL, this all should be this info is data type and the length. Student registration number, data type of student registration number is int integers. Integers mean you can enter only numbers. You can't enter characters. That mean in your registration number, I think only numbers available. No. So you can put how many numbers, how many digits for your number. Set it. Your registration number, I think 7, 8 or 9. Yes, 9. So that means you have to put here 9. Instead of 4, you have to put 9. 9, I think 9 digit. 9 digits, so you can put integer, int. But in earlier NIC number, at the end, you have to put V. NIC number, now the new numbers has only integer values, decimal digits. So I think I don't remember how many numbers. 10 or something. If it is 10, if the NIC has 10 integer values, you can put data type as int in the within bracket 10. Here you can put we can get as int 9. But earlier NIC number has V. So you have to put vacha. There's a character here, no? So in vacha, the length is 10. Here, student name is uh, what text. No need to add or something. So vacha and 54, 44, 5 length. We can in memory or database, it will allocate all student name as a 45 length. So it will you have to assign average length. Otherwise, the memory will be waste. Memory disk space, storage space will be wasted unwantedly if you now student A you have to write several names and you have to get the average and no actually maximum and some about say some another 10 we can include another 10 and put this value as the length. This value, I think we can go up to the 255, but most of the time, address unit more than the name. Date of birth is a date type. Gender is a char. Char is only one character. We can't enter two characters here. Student address Vacha, we can put as a 60. Student telephone number is a digit, only digits. It has only digit and 10 numbers. In Sri Lanka, 10 numbers. P code, Vacha, it has we give as a two characters. So Vacha and also now student registration number. These both should have these are called this marks table also has a student registration number. This connected to this one, this course code connected to this one. If the primary key is available in another table, this primary key is available in this table. Those are called foreign keys. If a table has a attribute, say of a primary key of another table, these attributes we call as foreign keys. According to this set of tables, what are the foreign keys? Please check. Just think and write. According to these tables, table name and foreign keys. You can write anything. Actually, marks table has foreign keys. What are foreign keys? Why you need to understand? No? Okay, think about what are the foreign keys and course code. Yes, one has written course code in which table? In which table? Yes, course code in marks table. Okay, thank you. Not only the course code in marks table, student registration number, also uh, for it, for it. Is an attribute primary key in another table. Both foreign and primary key must be same data type, same data type and the length. Now, relational data model. Example. I will explain details about the table. Now, in this table name is student. Attributes names. Now, attributes name, the table name is student. Attributes names are name, registration number, date of birth, gender, address, telephone, and the program. Field names are, we can write earlier, actually early days, we have to write like this, under with, you can't see, I think, underline, with underline, no, not underline, underscore, st underscore date of do, right? It should be very simple and short. Earlier we can include, and earlier, I think few years ago, but few years before 10 years, we can write only, I think, around 8 or 10, 10 characters field names. So we write as like that, stdop. We also, now also we can write like either like this also, or long name. We can write. Here, field length in 10. 10. This is char. Char has only one character length. Date type as it. The length is defined by this system, date. We can change varchar as we want, either 60, 45, like that, according to the maximum length of this length of the name attribute. Now we can fix registration number either 4 or 9 or like that. In this table, primary key is this one. Attribute registration number, field name st underscore registration number, primary key, not null, unique. Not null mean we cannot put the space, no values in this table. We can write registration number without the name. If we don't know the name, we can try. We can include later this name if it is not null. No, if you can keep it null, we can enter this row later, name of this row later. But your registration number, it is not null, so you can't put space without any number here. And also it should be unique. Unique means this row cannot be 1111. Row cannot be in another place. Here also you cannot put 1111 here. It should be different. If you assign this as primary key, this system MySQL will not allow actually to put the same value in different places. If we say accidentally we can enter, no, but it doesn't allow to enter repeated. Here gender is repeat. You can repeat it. Male, female. Date of birth, date of birth also, name also. If you want to put unique, you can put unique, but most of the it doesn't matter. Even it repeat. And here, all these things belong. All these attributes belongs to this registration number, except this program code. Program code is one student has only one program, only program code, so we can include it to this table registration number, not this all the things. Only the P code can be included. Here it is. P code is a foreign key. Foreign key, primary key of another table. This in this table we call row. Columns are this one, this one. There are how many columns here? 1, 2, 3, 4, 5, 6, 7. 7 columns are here. Columns, attributes. Yes, these are the things I have to explain this for this table. One-to-many relationships. One-to-many, many-to-many. One-to-many relationships, many-to-many relationships can be changed into the one-to-many relationships. Another thing is business rules to ERD. Most organizations are guided by the several rules obtained from this. A student may register for one or more courses is a rule. Business rule. These are called business rule. Belongs to the organization. They use that word. So get that word, that sentence, and put them in this and separate them into the table and store. Examples of business rules are: a student may register in one academic year for 0 or more courses. Student may register in one academic year for 0 or more courses. That is one rule. The course may obtain one or more students. The other side, a course may obtain by one or more students. Student obtain a mark for registered course. These are business rules. Relationship, I already explained it. Here you can see this ERD, this is called ERD. Okay, this ERD has attributes. Attributes belongs to the student. attributes belong to the course, entities are student and course. Primary key of course is course code. Primary key of student is registration number. Then now this student to course is many-to-many relationship. But to include to create in MySQL, you have to convert them into the one-to-many relationship. But so we can include in a include one relationship between these two entities. So registration number is relationship. Special attributes of this one is registration year. Here you can see change many-to-many relationship to one-to-many relationships. How? Student is available, course is available in left side and right side. In middle, we put marks. So this student marks for this course is this one. Student course for this course is this course. Student marks for marks of this student is this one, M3. S2 course is this one, student S2, marks is this one, like that. Marks, separate marks table. So now what happened? All these point is here. Here you can only see the point here. Point to expand to here. This side is many. This side also many. This side is one. This side is one. Here we will see different. Here in both sides, one to many, one to many. Both sides is there. One to many, both sides. So many becomes many to many. Here you can see this one side is here, one to many. The mark attribute should be added to register relationship. This mark appears in mark sheet. The mark sheet becomes an associative entity for the register. But in this mark, we have to put in a table. So we can put mark sheet as entity. As that is called here. That is called mark sheet. But what is this? Now here, there are so many standards for this drawing the one-to-many relationship. One is cross-put. This is the cross-put standard of the mark entity relations. This is actually this relationship become associative entity. These are the entities. This zero mean we can put sometimes we can put it as a zero marks. No marks can include no need mark. Sometimes he has not done the exam, so we can put zero or null. So it become zero here. Zero or marks here. If mark should be there, then remove this zero here and put this mark and like this. And here the entities primary keys are registration number and course code. And here, course code, registration year. All are keys for this to access this one. You can access student details by registration number. You can access course by course code. You can do this exercise. These anomalies mean you can see this. We have created relationships here. In MySQL, you can read this. You can create tables without these relationships also. What will happen if we not included relations here? If relations are not available, what happens? These are called anomalies. Insertion anomaly. One is inserting a department with no employees. Those all need we need business rules. We have to create. We can create a department if only employees are available. Without employees, that depend on the business. According to this one, inserting a department with no employees, we can create a new department. So if a business rules available, is department should be available, should not available without any employees. If this rule available, that is so. If a department create without employees, that should be not valid. So without relationships, without creating relationships, we can include. Deletion anomalies. Deleting the last lecture from the department will lose information about department. Updating. These all are updating, deleting, insertion. When one table data here, these anomalies. Now, without these relationships, we can enter student registration number, new registration number we can enter. We see if the registration number is 1111 all the ones, accidentally we write as 1, 1, 3 ones and 2. If this now, if this relationship is available in marks, even we enter registration number not available in student table, we can enter. If this relationship is not available. If this relationship available, if we enter wrong registration number, it checks with this student table. If it is not available, it appeared an error. That is called the insertion anomaly. And updating also, we cannot update here without knowing this, without adding this one. Course code is also like that. We cannot enter raw course code here if it is relationships. If this relationships available. Wrong. We have to enter course code here. We have to create course code. First, we have to create course code here, and then you can enter course code here. That is called anomalies. Normalization. Normalization is now without table, without any normalization. Registration number, name, program code, program name, all in one table. Course code, name, registration year, marks, all are available. But for this same student, these course codes are available. Same students, two courses, he has got two courses in this year. We can see it clearly, but these are data redundancy. This every time, this EEX3417 electronics registered here, all are available here also. 3335 available here. Here 3363, 336 is available. These are called redundancy. Unwantedly repeating values are there. First, when you are normalizing, first you have to remove these things. Here you can, this is first normalization. You can remove repeated values separate into two tables. Registration number, we can include registration number here. Registration number 1111. Course code is this one. But here also course code is repeated again. This also should be the second normal form. We can separate student and program code and the registration number course code. Now we can get separately course code here. Second normal form is this. Normalization, third normal form is this program code also we can get separate. Every non-key attribute in second normal form depend only on entire primary key. That means if we change this name, this registration number also should be changed. Here, if this attribute change, this primary key also change. Here also, this registration number are changed. All these things are changed. In first normal form, we can say electronics 1, we have to enter electronics 1 although in every places, and but it is even these are not changed. If even we change, these we can keep as same. This every non-key attribute in second norm depend on entire primary. Non-key attributes are this one. Consider the following relations books, ISBN, these are things. Assume that following function dependencies exist on the relation ISBN, books title, publisher, books type are depend on this. Price is depend on this type. Postal address is depend on author. Now, this data modeling is finished. Now, I will explain about this first. Octave. You can get actually Octave online also. Here the Octave command prompt. One student asking, can we get the slides? Slide, I think, available in LMS. I will include this video also, upload to the upload to in LMS. Introduction to Octave. These first slides are for the to Octave. You can download also in your computer. I am using. You can use this one also, Octave, and you can use online also. Most of the here 2 plus 2. This is command prompt. 2 plus. You can see answer is 4. Two into sine sine 2 5 into 2. Answer is this one. Yes. Now, 5, the value of 5 is this one. I think you can see, no? You can create array. A1 is say this one. Here, comma is in one row, the values of one row. Here there are two rows, two columns, 2, 3 is in one row. Then semicolon. Then 4, 5. In this one, there are three columns, one row, 2 rows, 3 columns. A is equal to 2 into 2 to 6. It will write 2, 3, 4, 5, 6. Zeros 1 to 5. One comma 5. Now multiplying two matrix. A1 is 1 semicolon 2. This bracket, okay? 1 semicolon 2. A2 is 2 semicolon 4. Now A3 is equal to the A1 into A2 multiplying. You have to put star mark here. Dot. Yes. If you are multiplying in a single value, you can directly multiply. You can, if you want to multiply two matrix, you have to put dot for the first one. To plot this angle zero 5 divided by 3.2. 5. Is 0 to 25. Y is equal to sine angles. Plot angles Y. Here is the plot. You can easily calculate and draw plots like this. Okay. Another plotting is in book
We can't hear you, sir.
Sorry. From which point?
About 2 3 minutes, we cannot hear you.
Did you can write this one?
Before that,
Okay, I will explain. Sorry. This is plotting graph. Plot graph. You can right click like this. These are available in books, okay? Textbook. Here, in this one, angles. Angles are space now. Here, there are how many points? Now here, duration is for one step to another step is 5 by 3. Okay. Now see up to 2 5 up to 2 now 5 value is 3.12 I think. 2 5 is 6 point something. Up to this value, from this value up to this value, uh, uh, steps by 5 by 3. When you write this command, you will get these values. First one is 0. Last number is 2 5. In between that, 5 by 3 values. And then sign value of this one. Here, this one. The plot is this one. Now, if we can increase the duration, now this is the duration. If we increase the 6, the duration between one sample to the another sample, duration become small, and then number of samples maybe is increased. Here, it will be smoother than earlier one. Smoother than this side. Now, first we get the angle and then get the sine wave. So it becomes smoother. If we increase this division more, then sine values plot smoother than this. Sample, if the sample size is shorter, duration, one sample to another sample, if it is shorter, the sine waves become increased. That is another one. If else statement. You can use there is another. Yeah, you can try these also using Octave. Okay. Now these are for the information only to read only. No, you will not get very simple like arrays. We will give as questions. Other than that, we will not give a complex question from this Octave. Okay, then thank you. I will. I will wind up this session. Okay. Do you want any other video discussion for this? Okay, I will upload assignment also later.